Hello, welcome to True Projects. In this video, we are going to explain about deep reinforcement learning approach for autonomous agents in consumer-centric electricity market. Introduction. The project seeks to overcome the issues provided by the growing usage of photovoltaic panels in which individuals generate their own electricity and sell the excess to agents who then distribute it to other consumers. The project presents a deep reinforcement learning approach for autonomous agents in the consumer-centric electricity market to optimize this process. Agents, an environment representing electricity production and consumption, and a reward penalties system comprise the reinforcement algorithm. Based on the available energy, the agents forecast when to buy or sell electricity. For training, the project uses self-generated dataset derived from Kaggle energy consumption and production data. The purpose is to empower market participants to make educated decisions about buying and selling electricity. Objective. This project's goal is to provide a deep reinforcement learning (DRL) approach for autonomous agents in the consumer-centric electricity market. With the growing usage of photovoltaic panels, consumers generate their own electricity and sell the excess to agents, who then distribute it to other consumers. The DRL algorithm enables agents to optimally predict when to buy electricity from producers and when to sell it to consumers. The agents use available energy data to make right judgments for buying and selling electricity while operating in the electricity production and consumption environment, earning incentives for correct actions and penalties for incorrect ones. The project's goal is to develop an efficient and informed power market that benefits both consumers and agents. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system Windows only, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. In software requirements, we have Python IDEL with 3.7 version. Methodology. To implement this project, we have designed the following modules. The first module is Upload Electricity Consumption Dataset. In this module, the electricity consumption dataset is collected and prepared for analysis. The dataset contains information such as time-stamped electricity consumption data from various consumers, historical electricity prices, weather data, and other relevant features. The dataset will serve as the input to the DRL algorithm. Second module is Pre-processed Dataset. Data pre-processing is a crucial step to clean, transform and organize the data before feeding it to the DRL algorithm. It involves tasks such as removing missing values, normalizing or scaling the data, encoding categorical variables and splitting the dataset into training and testing sets. Proper pre-processing ensures the quality and usability of the data for training the DRL model. Third module is Run Deep Reinforcement Learning. In this core module, the DRL algorithm is applied to train the autonomous agents. The agents interact with environment, electricity production and consumption through a sequence of actions, observations and rewards. The DRL algorithm, often based on techniques like deep Q networks, DQN, proximal policy optimization, PPO, or advantage actor critic A2C, learns to optimize agent behavior over time based on the rewards and penalties received during interactions with the environment. Fourth module is Rewards Graph. The rewards graph is a visualization that shows how the agent's performance improves over time during the training process. It plots the cumulative rewards received by the agent against the number of training iterations or episodes. As the DRL algorithm progresses, the agent should learn to make better decisions, leading to increased rewards over time. The reward graph helps in monitoring the training progress and accessing the effectiveness of the DRL approach. Execution. For the execution of the project, we need to open the code folder. This is the code folder. This is the dataset folder. This folder contains energy file. Importing this dataset contains the information of date, time, ID, name, geoname, etc. This is model folder. This folder contains .h files stored, which contains algorithm information. These .h files can be loaded into the project code during runtime to utilize train models. This is main code file. This is run.batch file. Instead of executing our project in the command line interface, we have created Windows batch file to execute the project. Double click on run.bat file. This is the graphical user interface which we have created using Tkinter library in Python. Using this GUI, we will interact with the project. Click on Upload Electricity Consumption Dataset to upload the dataset. Select the energy dataset, open it. So we can see that the dataset is loaded and the dataset contains both numeric and non-numeric values. These non-numeric values are not accepted by the machine learning algorithm, so these must be pre-processed. Now click on Pre-processed dataset to clean the dataset. So we can see that the dataset is cleaned and we got the total records found in dataset. Now click on Run Reinforcement Learning to train algorithm and take action on test data to predict energy consumption and production. In above screen, for each test data, algorithm has predicted whether agent has to purchase energy or sell energy, and after selling we got available energy details, and the same is seen in the graph. So this is energy sale and purchase graph. X-axis represents number of days and Y-axis represents require energy to sell and purchase. And in above graph, green line represents available energy stock and blue line represents energy stock to purchase. And by seeing above graph, energy agent will understand require energy selling and purchasing for next 50 days. Close the graph. Click on rewards graph. So this is the reinforcement rewards and penalty graph. X-axis represents actions or episodes and Y-axis represents rewards or penalties. And we can see most of the time algorithm got high rewards and less penalty, as algorithm will predict closer to accurate value. So in actual requirement and predicted values, little differences will be there. And those little differences called MSE, mean square error. So the lower the MSE, the higher is the reward and lower is the penalty. Close the graph. And the final conclusion of the project is the project employs a deep reinforcement learning DRL approach to enable autonomous agents in the consumer-centric electricity market. By forecasting the best movements to buy from producers and sell to consumers, the agent becomes well-informed and efficient market player. The reinforcement algorithm, which involves agent, the environment, rewards and punishments, aids in making accurate decisions. To properly train the algorithm, the project employs a self-generated dataset as well as Kaggle energy consumption production data, as it optimizes power distribution and improves overall market performance. The DRL strategy illustrates its potential for developing an intelligent and responsive electrical market that benefits both customers and agents.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.